Okay. Um, yeah, one of the things that you might notice is that I will hold my whole talk in English. Um, well, there are multiple reasons for this. First of all, maybe there are people in this stream right now who are not, well, that well versed in German. That's the first thing. And the second thing is that during my everyday, like in everyday work, I use English all the time. So even if I were to hold this talk in German, then almost every second word I would say would be some kind of English word. Be it, I mean, it's the game industry, right? I think we all should be familiar with that. We are using quite a lot of English words, be it games, game engine, and all of these other related terms. So I might as well do this talk in English from the get-go. Yeah, and the thing that I want to talk about today is reconnecting in multiplayer games. I just had a short introduction of myself already, so I will glance over this. Yeah, my name is Thomas Valentin Klink, but nobody calls me Thomas, just call me Valentin. Yeah, I've been working at Crytek for over 4 years now. And the main title that I have been working on is called Showdown, which is this game. Maybe you have seen art of it somewhere, who knows, maybe you have seen gameplay of it. Yeah. We're going to get back to Hunt at a later point because, well, while my talk is about reconnecting in general in the beginning, later on I am going to talk about implementing a reconnect functionality into Hunt Showdown itself. So just as a small post-mortem. But as I said, we're going to get to this later. So let's start. There are some things that we need to clarify before I dive into this talk. And some of these things are just general concepts of, well, network programming, making a game networkable, so to say. And other things are what even is a reconnect, stuff like this. So before I start talking about reconnecting in general, maybe we should first clarify what a reconnect, or what I mean when I talk about reconnecting. Well, probably most of you, if not all of you, have played online games during your life. And most of these games have some kind of reconnection functionality. What I mean by this is if we take, for example, like any modern game, I don't know, League of Legends, for example. If you lose connection to the server while you play, then usually you have the capability to reconnect to an already running match and basically, diving back into it, not abandoning your teammates or abandoning your player character, but instead going back into the game because you have, for example, lost the connection to the server. Maybe your PC crashed, maybe the client itself crashed, like the game client crashed. Can be a lot of causes, but a game gives you just any kind of functionality to reconnect to an already running game. This is what I am talking about when I say reconnecting. So now and another precursor is that this talk is quite technical in the beginning. I'm trying to make it as understandable as possible, but the very nature of making a network game, like an online multiplayer game, it is quite technical. So please bear with me. As I said, I'm trying to make this as digestible as possible. So, well, let's start with the first thing, which is that, this seems super simple, by the way, but, well, it's just the introduction, of course. So, probably all of you who have worked with computers or worked with programmed something in the past know that internally inside of PC, everything is just ones and zeros. And well, over the last few decades, we have abstracted this all away. So when I, for example, sit in front of my PC right now, then of course I do not interact that closely with hardware that I care about these ones and zeros. People have written operating systems like Linux or Windows, which makes all of these, well, computer processes more approachable for us, more digestible. And the same can be said about programming in general. Like today, when we write a program or write a game, we no longer work with ones and zeros or even with assembly most of the time, but we are working with quite abstract languages. In the games industry, for example, C# used in Unity or C++ are, I think, the most dominant one. Don't quote me on this. This is just a educated guess from my side. So we have extracted these ones and zeros away. And the same thing can be said about network, sending data over a network. Well, of course, data in your PC is just ones and zeros. And when you communicate with another PC, as we do for a multiplayer online game, then the data that we send and receive is just ones and zeros as well. And just as we did in the past with programming languages, we also abstract away these ones and zeros when we send data over a network. Game engines, like the popular ones, be it Unity, the one that I use, which is CryEngine, or Unreal, all of these have some kind of network system implemented in their engine, which makes it easier for us as a game programmer to send data over a network and to communicate with other PCs somewhere around the world. And by now, there are many ways how you can implement a multiplayer system over a network. But at least the three engines that I've already mentioned, CryEngine, Unity, and Unreal, they all share, let's say, a standard tool set. They have different names for those, and they are interacted in different ways, but all in all, the same concepts apply to all three of those. And we need to talk about two of these tools in there, because we are going to compare these two when they are applied to a reconnecting functionality. So the first tool of the trade that we usually use when we implement a multiplayer online game is called an RMI. Some engines call these RPCs, but these two abbreviations are completely synonymous to each other. Like RMI stands for Remote Method Invocation, and RPC stands for Remote Procedure Call. Method invocation, procedure call, it's all the same. So basically what this is if I want to tell another PC, like I am currently playing a game, let's say I play Fortnite, and then I'm sending a message over the network to the server that stands somewhere around in the world. I can, for example, send this message using an RMI, which is just a fire and forget message. It's a one-time message. I'm telling that other PC that something has happened. Maybe I've pressed a button, or maybe that other PC is telling me that I have just received damage. It's just a one-time message. It's as simple as can be. Should be rather straightforward to visualize. We're going to take look at some examples of these RMIs in a minute, by the way. This is just some to lay a bit of groundwork in the beginning. So there are RMIs and RPCs. And by the way, from now on, I'm going to refer to these as RMIs simply because it's the term that I use in everyday work. Well, opposed to these one-off messages that you just send once, there is something, well, that does not have like a unified name, but you could call it continuous state serialization. What I mean by this is, as opposed to these RMIs, which we send one time, this continuous state serialization takes a look at an object instead of a game. Like, for example, you have a game object somewhere, and this game object has certain properties. If you, for example, were to play probably any kind of first-person shooter, then one of these properties would be the position of your player character, or maybe how much ammunition you still have, or maybe how much health your player character has. Like, this game object has some kind of state. And if we make use of this continuous state serialization, we are not sending one-off messages over a network, but instead we constantly, like repeatedly in certain intervals, we tell everyone who's interested in that, like every player inside of our match, what the current state of this entity, of this game object is. Like we continuously tell everyone, by the way, this entity is now at position X, and now this entity has this much health remaining, and this entity now has this much ammunition left in their magazine. Stuff like this. We continuously tell it. CryEngine calls this concept aspects. Unity calls it syncvars, and Unreal does not really have a name for the variables itself, but in Unreal, usually this is referred to as replication, like in general, this whole concept. Same for RMIs. I'm going to use aspect as the word of my choice here, simply because it is the one that I'm using in everyday work. Okay, so basically from this first slide, what you have to keep in mind is just there are one-time messages, and then there are like continuous messages over network that tells other PCs about the state of our game. Now, I want to show you a super, super simple example game. I mean, it's as simple as can be, but I will use it to demonstrate some of these concepts that I've just explained. So the game that we have is very simple, as I said. It's just two spaceships floating around in an endless void. They both have some health, which is displayed with the green health bar below. And what these spaceships can do is they can fire a shot. This shot can fly to the other spaceship, and then that spaceship can take some damage. And maybe in this case, you can see that it is damaged somehow. Super simple example, but it has to be simple because we want to explain the concepts that I've just mentioned applied to this example. So let's take a look back at these Rmis or RPCs as they are sometimes called. I've already mentioned that they are fire and forget, as in we send these once. These are for one-off events that happen inside of your game. And yeah, you basically, that's the gist of it. You send them once. That's the thing about RMIs. Now, as I said, they are used for one-off events. I want to give you 2 examples for this. In general, we have to differentiate in network programming between the server and the client. I suppose most of you who have somehow delved into or even played any kind of multiplayer online game have already some understanding of what this is. Basically, the server is the one who actually decides everything that is happening in your game, and the client is actually the game instance that you open up on your PC to, for example, play whatever, Fortnite, Rocket League, League of Legends, and all of that stuff. Now, I want to give you 2 examples for these RMIs. And the first one is when the server gives us a message. An example for such an RMI could be that I, as a player, have just received damage. Like, for example, somebody else shot at my character, that shot was validated, now I have received damage, and the server tells me so. For example, as a response to this message, there could be a little hit marker somewhere on my screen if we are playing a typical first-person shooter. Opposed to this, there can be another message sent from the client to the server, and one example for this would be that a player is requesting to interact with an object, for example. Maybe I still am in a first-person shooter, there's something in front of me, and there's a little prompt that says press F to open the door or something like this, and then the player presses F, and then a message is sent over the network that I as a client had just requested that I want to open this door. This message is being sent to the server, and then something else is happening in response, probably that the door is being opened. Just 2 examples, quite simple, and as I said, for one-off events. Now, this is quite important because RMIs, as we will see, are rather straightforward to conceptualize and also to implement in most game engines. Like, if I'm just taking a look at these messages here, like a player or you as a player have received damage, or you just requested that I want to open a door. Like, these actions, so to say, are quite easily translated into just everyday language. Like, I can translate this message into, well, I want to tell the other PC that their player character is just taking damage. Now, applied to our example game, one example for such an RMI would be that in this example, the left player, which I refer to as player A now, and the other one is player B, that player A wants to shoot. Like, maybe they just press the spacebar, and now in response to that, a message is being sent to the server, which tells the server that the server should spawn a bullet. Like, that is one example for an RMI in this very simple example project. Another example would be that once the bullet that this player A has shot has hit the second spaceship of player B, and then such a message could be, you lost 10 health. Like, this is just being sent over the network to the client that tells them, a bullet just hit you, now you have taken damage. Rather straightforward, I'd say. Now, opposed to this are these, well, aspects, as I call these. I've already mentioned how aspects differ from RMIs in that they continuously send a state over the network. So they observe whatever object it wants to synchronize over network, as with our example, it could be these spaceships. It's continuously observing these spaceships, and whenever a state, whatever state that might be, but whenever the state of this spaceship is changing, it is sending an update message over the network so that the state between the server and all of the clients that currently play the game is the same. In general, this is used not for one-off events, but instead it is used for any permanent object, or at least an object with a certain lifetime in your game. One of the typical examples would be, well, a player object. In our case, it's the spaceship. Spaceship is there for as long as you play the game. In a game like League of Legends, it would be your champion. In a game like Fortnite, it would be your player character, which wields the weapon and with whom you shoot your bullets into the world. But it not only applies to those kind of game objects inside of your game, but also to anything else that can be lingering. Like in Fortnite, it might be when you place down some kind of barricade, or when you build any kind of other building. These are objects that stay in the world, and maybe you need to keep the state of this object in sync. This is what aspects are used for. Some examples would be, as I said already, but the player's health or maybe the position of an entity in the world. Maybe you have a game that works in different stages, as in maybe you have a lobby and you first wait for all players to go into this lobby and afterwards you go into the actual game state. Maybe you want to synchronize this current state of the game over the network, or maybe you have a score inside of our game, inside of your game. Maybe you have some kind of the enemy team has already scored 20 goals, and you yourself have not scored a goal at all. So maybe you want to synchronize this match score. And all of these things, they are not one-off events. You permanently want to be informed what the current state of the game is. This is what something like an aspect is used for. Now, as opposed to RMIs, aspects require more maintenance on your part, usually at least. So RMIs are quickly written and they are rather straightforward to conceptualize. Aspects sometimes are not that easy. And also they require more work on your part. Yeah, like you need to think about what do I actually need to synchronize over my network, like the health and the position and what the game state and the match score and all of that stuff. You just have to think a bit more about this. And you also need to, well, maintain it. Now, whoops. 2 examples, as again applied to our example game, is that player A is, for example, at location XY and player B has 90 health left. What is important about this is the right example. Player B has 90 health left. It's basically like an inversion of what we had previously. With RMIs, this information of that this player on the right side has taken some damage is, for RMIs, it is more like an active action, telling that player you have just lost 10 health. With aspects, it's more like a passive version of this event, which is player B has 90 health left. It basically only tells the client about the outcome of this action, instead of what this action actually did, this action of a bullet hitting your spaceship. Now, so we should, before we go to the topic of reconnecting, we need to talk about something else in network programming in general, which is what exactly do we even send over the network here? Like, of course, we're sending that player A is currently at location XY or player B has 90 health left. And whether we send this using RMI or via aspects, it does not matter because we're still sending messages over the network. But what exactly do we need to send over the network there? Like, how do we determine what we need to send and what we don't need to send? And maybe this seems rather basic, but I still want to talk about it because it is important to, in the end, define what a reconnect really is. So, in general, what I want to explain to you now is the difference between static and dynamic data. If you have ever played some kind of online game, you probably remember that when you play such a game, you have a launcher in the beginning, and then maybe this launcher is checking whether there is a new patch for this game. And if there is a patch, then it downloads all of the data that came with that patch to your PC before you even enter any kind of match. Like be it the League of Legends launcher or whatever, it does not matter. It usually downloads some data beforehand. And this data I refer to as static data, as in this data is not defined at runtime. Like some of the examples for this is when you download a patch, then some of the static data included in this patch would be a level. It's the same for every player, and it's things that do not change between matches. Like maybe the 3D models, the prefabs, if you are working with Unity, for example. Or maybe it's the textures, the audio clips, whatever. The materials used in your game. All of these things, they are not sent over the network because you can synchronize these things beforehand. Like before you even start a match, you can just send over all of this data over the network so that everybody more or less has the same base to go from, like the same game file. Theoretically, what you could do is, of course, when you play a game, like I'm using this example quite a lot right now, but if you play a game like a Fortnite or League of Legends, theoretically, there's nothing preventing you from starting a match and then every mesh and every animation and every texture and all of that is transmitted when you start the game. But of course, this is super inefficient because you don't have to do this, and playing a match would take ages. Instead, you basically download everything that you can download beforehand. This is what static data is for, everything that you can download before you even start a match. Another thing that is technically static data is something that happens in response to dynamic state changes. before I go over this point, I first have to clarify what dynamic. Well, actually, we'll come back to this point in a second. Some examples for static data for our example game here would be the spaceship sprites, or maybe the health bar sprites. Maybe if a spaceship is hit, we play an audio clip. This audio clip would also be static data. Like, we don't send this over the network. What we would send over the network is, for example, a message that you have taken damage, and in response to this damage, we play a sound file. This is what I mean when I talk about follow-up events to dynamic state changes. We have received damage. In response to this, we play a sound file, but we already have the sound file on our hard drive. This, for example, is another one of these response events. We have taken damage, and now we display a little destruction particle, for example, on our right spaceship. Now, as opposed to static data, there is, of course, dynamic data. And dynamic data refers to everything that can change at runtime and only at runtime. Usually, this is stuff that is dependent on input from the player. Like the health of a player character, or the position of the player character, or maybe you throw a grenade in a first-person shooter. This grenade then, of course, is also something that is determined at runtime based on player input. And all of this data that is determined at runtime, I refer to as dynamic, because we can't foresee these beforehand. These are dependent on player input, and players just do what they want. And the same goes for entities that were spawned at runtime. I've just mentioned this example of a grenade that you throw, like maybe, as I said, or I said repeatedly, you have a first-person shooter, you throw a grenade, and this grenade is now in the world, and after, for, 3 seconds, it explodes. Then this entity is one that is spawned at runtime, and this entity is relevant for other players. It is relevant for the game flow, because other players may see this grenade, and then they try to dodge it, so they don't get killed by this grenade. This I refer to as dynamic data. Some examples in our game here would be the current health of players, for example, or the flying bullet. And with the flying bullet, I mean not only the position of it, but also that it even exists, because like, from a very basic level, bullets don't need to exist at any point in time inside of your game. If no player shoots, then there are no bullets. Though one of the or something that is part of the dynamic data of this example game would be even the existence of a bullet. Now, now that we have these prerequisites of Rmis and aspects, and also static and dynamic data, I want to take yet another look at Rmis. So, Rmis, as I said, they are just very comfortable and fast to write. They are more or less very easy to conceptualize. If you have ever written an online multiplayer game in one of the, maybe by yourself, maybe you've used a custom engine, who knows, or maybe you have used an already existing system in Unity, in CryEngine, Unreal Engine, does not matter. You've probably noticed that writing in Rmi is quite comfortable. Like, usually these network layers, these engines supply, they make it very easy for you to send data over the network using an Rmi. And I have also mentioned already how Rmis are sort of like an active way of sending data, while aspects are more like a passive way of sending data. An Rmi could translate to you have lost 10 health, while an aspect can translate to you have only 90 health left. Basically states the outcome. Now, from my experience, a lot of online multiplayer games over-rely on Rmis. What I mean by this is that sometimes there are cases where it would be better to synchronize data using one of these aspects that continuously observe an entity inside of your game and then continuously sends the state of that entity over the network. But instead, the state of this entity is synchronized using Rmis. Back in university, when I started writing my first multiplayer online game, I too did this. Like, probably even today, I do this from time to time. And the reason for this is just that Rmis, they are just faster to write. That's pretty much it. They're faster to write. You don't have to think about it too much. And they are more comfortable for you as a programmer. And at first glance, you might think that this is not really a problem, because whether we send, well, with the example that I have written above here, you have lost 10 health versus synchronizing that you have 90 health left, the outcome is the same, right? As long as you send all necessary data for your game to work, then who cares? Like, it's still transferring the same data, just formulated in a different way. So, well, where's the problem? Well, there is a problem with this, and now we actually come to the whole thing of reconnecting. What exactly is reconnecting? Well, now that we know this vocab or have these specific terms, static data, dynamic data, atomized aspects, we can actually talk about what a reconnect is supposed to do in your game. Basically, when you reconnect to an already running match, then all of the dynamic data inside of your game needs to be resynchronized to this player that have just reconnected. The static data we don't care about because we already have this. But everything that has happened at runtime based on player inputs, for example, that needs to be resynchronized to a player that just reconnected because they have no prior knowledge of it. Basically, they run into a completely new game from their perspective, and now you need to tell them what the current game state is. That is what reconnecting is about. And now let's take a look at the two methods that we have used or that we have got to know so far in regards to sending data over network. Aspects work in this regard quite nicely because aspects continuously, as I said, observe an entity and send this data to everyone who is interested in it. And if somebody reconnects to us, then, well, we don't really care about this. Like, we still take a look at our object, and then for this newly connected player, we are just going to take the state of our object and synchronize it to that new player as well. Like, aspects pretty much work out of the box with reconnect because what needs to be done for reconnect, sending dynamic data again, aspects do automatically. With atomize, there is a problem though. And the problem that arises with atomize and reconnecting, I want to visualize again with our example game here. The reason why I have used this very simple game is, well, because we don't need a very complicated one, of course, but also because it only has very few states in which the game can be. What I mean by this is, we more or less have 4 states in this example here, which is, well, the upper left one, where there are just 2 spaceships, and we don't care about their health right now. It's just 2 spaceships floating in the void. They do nothing. Then the upper right one, which is that a player has just launched a bullet. Then the lower left one, which is the bullet is on the way to the other player. And then the last state, which is the other player has taken damage. Only a few states in this game. Now, what we want to focus on is this lower left example of a player shooting, or that a bullet is on the way to the other player. Now, this is quite a typical example for something for your first project. If you want to make something work over the network, like I remember back in university, this was the assignment that we had to do, write just a game, a side scroller in this case, like Metroid, for example, where a character can shoot a bullet and it's all in 2D, and this bullet can travel around, and if it hits another player, that other player is damaged. So for this, we now have to get a bit into gameplay programming and think about how would you fire this bullet? How would this work from code side? First, we have to identify what does a bullet really do. For our example game, the bullet is very simple and very naive. Basically, what it does is it travels in a single direction, it never changes direction, and it travels at a constant speed. So it has no drag, and it also does not accelerate its velocity over time. It is always traveling in one direction, and which is also banned. It travels in one direction, and it does this at a constant speed. It never changes. And if we now take into account our 2 methods of synchronizing something over the network, we can come up with 2 solutions to this. The first one would be the Rmi solution, which would be, I, as the server, tell a client, please spawn a bullet prefab, and this bullet prefab contains all of the information about that a bullet travels in a single direction, it travels at a certain speed, all of that stuff. This is all in static data. Like, if I tell a client spawn a bullet, the client knows what it is supposed to do. It spawns a game object, it looks like a bullet travels in a direction, and this direction does not change, and the speed also does not change. So the Rmi version would be, client, please spawn a bullet prefab at location XY, and it should travel into direction X2, Y2. XY and X2, Y2, this is the dynamic data in this equation, so to say. And this is the data that we send with our Rmi. From there on out, as soon as the server sent this data to a client, basically the server is done, or this whole mechanic is done in terms of networking. The bullet has been spawned, the bullet will travel to whatever target it is currently targeting. Nice. Now, as opposed to this, there would be the second approach, which would be the aspect approach. And in this case, we still spawn a bullet prefab somewhere, in this case at location XY, but then instead of already knowing in which direction it will travel, we instead constantly tell the client the state of this bullet in the following seconds. Like spawn a bullet at location XY, then bind this bullet to the network, and every other position that this bullet will take, or this bullet will be in the future, it will be resent by the server, because the server is constantly observing this bullet, and then it will notice this bullet has changed position, well, because it is traveling at a certain speed into a certain direction, and it will inform all clients about the new position of this bullet. It seems a bit maybe simplified, but we can already see that for the Rmi, like the description is 2 lines, and for the aspect it's 3 lines. And also in terms of network traffic, the Rmi only has like 4 variables really. The X location, Y location, and then the same thing for the direction. While for the aspect, we constantly have to resend the data over the network. It is there's much more processing involved in this. But again, back to our example. If we were to implement this whole bullet mechanic using our first method of the server telling the client once to spawn a bullet at a certain location from where it travels into a certain direction, then we'll get into a bit of an issue, because this state in the lower left corner of a bullet flying is dependent on a previous state. And the state it is dependent on is that a player has pressed the spacebar and shoots a bullet. So the lower left state is, as I said, dependent on the upper right one. Without the upper right one, the lower left one cannot exist. And if we have used our Rmi method of sending only the initial event, which is a bullet has been spawned and it will travel in this direction, then we get into trouble if we want to reconnect in the lower left state. Let's say I'm just starting my game and I am now reconnected to a running match, and and the game is currently in the lower left state. Well, then what will happen is that I will not see the bullet. In this example, the upper image is what is actually happening in the game. Like there is a bullet, the bullet is currently traveling to my spaceship. Let's say I'm player B, the right one, the red one, and there is a bullet currently on the way to me. I do not know this though, because when I reconnect, I do not get constantly updated about my bullet, but instead the server basically assumed that when it sends this message of a bullet has been spawned, the bullet state has been simulated locally on me as a client. But if I have never received this Rmi in the first place, well, then I do not know that a bullet has been flying to me towards me for the last few seconds. Therefore, the synchronized game state is broken. I do not see a projectile heading towards me, and if I don't see it, then I cannot react to it. And because of this, what is actually happening is that a bullet is flying to me, I don't see anything, and therefore I, from my perspective, receive damage out of nothing. Like, I did not see projectile hitting me, I just received the result of this, which is I have lost 10 health. And I, as a player, would be totally frustrated, because what is this? Like, is this game bugged? And players, rightfully so, will complain about this, because I, as a programmer, have not made sure that every state inside of my game supports a reconnect feature. Like, if a player, we don't know when a player will reconnect to our game. If they have lost connection to my game, they can reconnect at any point in time. I can't foresee this. Whenever their network connection works again, they might be able to reconnect. And if I don't make sure that my game works at all points in time, well, then player frustration is already foreseeable, and players will complain about this. Now, if you, and now I've bashed Rmis quite a bit, but I still want to talk about how, yes, even Rmis have their place when you want to reconnect. Like, it seems with this example, like everything of your data inside of your game should be synchronized using an aspect, which is not the case, because Rmis are still totally valid. What you have to do in case that you have synchronized data over the network using an Rmi is that once a player reconnects, you can, of course, check that, like you now have a player back into your match. And what you need to do in that instant is that you collect all of the dynamic data in your game and then send yet another Rmi that contains all of the current state. Again, like, you don't make use of these automatic aspects that do that for you, but instead you send an explicit Rmi of the network. Hey, welcome back to me as the server. I'm going to send to you all of the game state right now in one big message, roughly speaking. So even with Rmis, reconnects are totally possible, but you have to keep this in mind. Aspects work out of the box. RMIs do not. You need to manually send them. As I said, if you have used aspects from the beginning, that would not be a problem. But if you have kept all of this in mind, like if I use RMIs and I support Reconnect to my game, then I'm going to write my RMIs in a way that, well, they still support this Reconnect. They support a player Reconnect to my game at any point in time. Then everything is still fine. You just have to keep this in mind. So using an RMI in a Reconnect scenario, it's not the worst case in the world. Like, it's not that bad as long as you kept this in mind. Now let's go to the worst case scenario. The worst case scenario is that you have a finished game which already has a working multiplayer. Like, people can already play this game, maybe it is already released. And unfortunately, this multiplayer is dependent on RMIs in a lot of places. And so far, your game has not had support for a Reconnect feature. So it does not matter, because if you don't support Reconnect, then this whole issue that I've just mentioned does not apply to you. But now somebody comes along and says, hey, please implement a Reconnect feature into the game long after it has been released. And now we can take a look at Showdown, because this was exactly the case for this game. Quick brief of what Showdown is. Showdown is just a first-person shooter made by Crytek. And in this game, roughly speaking, you have a squad of 1 to 3 players. You walk around on the map, and then you can shoot at other players and other AI, and you do stuff on that map. The important thing here is just that it is a first-person shooter. You have other players in the map, and the game is like match-based. You go into a match, you finish that match, afterwards the match is over, and you return to the main menu. So, this is like a bit of a spoiler. This is how the Reconnect feature looks inside of the game. You come back to the main menu, you get a prompt that says, oh, like, we noticed that you have left the mission, but you did not actively leave the mission. So do you want to reconnect to your running match? It will tell you how long this mission will still last, and then you have the ability to either say, yes, I want to reconnect, or no, I do not want to reconnect, and in that case, you abandon your teammates pretty much. Okay, like a prompt like this is quite typical. You see it in a lot of other games that have this functionality. Okay. Some context as to what made this reconnect feature in Hunt a bit difficult. So this game was released into early access almost 4 years ago, in February of 2018. So it has been on the market for quite some time. And well, the release, like version 1.0, where we went out of early access, was in August 2019, which is also over 2 years ago. And Hunt is a live service game, as in we continuously give it updates, and therefore if we continuously give it updates in certain intervals, then the code is also changing all of the time. Like, we fix bugs, we implement new features, code is changing all of the time. And unfortunately, like, game development has deadlines. Like, at some point, somebody will say, we need to put this game out, and you as a programmer usually have not a lot of saying in this. Like, at some point, games have to be released. And if you have a deadline like this, then of course, sometimes you come to a situation where you have to make compromises. And in this case, the compromise was, in Hunt case, I mean, that a lot of data was synchronized using RMIs. We did not have a goal of having a reconnect feature inside of the game. This was just not a priority. And using RMIs, as I have said repeatedly, is just quite fast to conceptualize and fast to implement. So a lot of data in this game was sent using RMIs. Maybe some of you are already familiar with, well, it's not really a saying, but if somebody asks you to implement multiplayer into an already finished single-player game, it can be very rage-inducing. Like, retrofitting multiplayer into a single-player game, sometimes you have to rewrite your whole game for this. This is a huge undertaking. Now, on the other hand, implementing Reconnect feature into an already working and finished multiplayer game that did not have a Reconnect feature up to that point, well, it's also bad, but it's not as bad. Like, it is still tedious work and can be a bit annoying, but at least it's not as bad as retrofitting multiplayer into a single-player game. So, before I come to this postmortem part of this talk, and yeah, I still have 5 to 10 minutes left, this should work out. Okay. So, in Hunt's defense, I want to mention some things that, just about general development here. So, one example would be that sometimes even state-related data that you would usually synchronize using an aspect can sometimes be synchronized using an RMI. One example for this would be, in our case, the death recap. Just a quick look at it. Basically, if you die inside of this game, you will get an information screen that tells you how you died, who you were killed by, and there will also be a little damage history where you can take a look at what happened shortly before you died. Like maybe somebody stabbed you in the back and that did some damage to you, and this is why you also died from the bullet that hit you in the shoulder, something like this. So, in general, the questions that are answered by the screen are who, what, where, how, all of that stuff. Now, because afterwards you are in a death state from which you can be revived by your teammates, you might say that you could think about synchronizing this using an aspect. Like the state in this case is you are dead and this is how you died. Like it is somewhat related to a state of you dying. This death information is tied to this death state. So maybe you are thinking in the beginning, yeah, I could synchronize this using an aspect. Well, there is a problem because, well, it's not a problem, but there is a counter argument for this, which is there might be a case where you don't actually die. Like you don't need to die in Hunt. If you are a super good player or you simply never engage in any PvP combat, then you might not ever die. So this aspect data, one of the caveats of this is that you continuously observe it and you continuously send it over the network. And you do this even if the data is not needed. With Rmis, you only send this data when it is actually needed. So in the case of this death recap information, it might actually be wiser to send this using an Rmi, because, well, you might not even die inside of the game. And if you were trying to observe and serialize this death recap information of the network, sometimes it's in vain because you don't need this information in the first place. So in this case, sending over this death cap information using Rmi might actually be the better choice. Of course, if you do something like this, then you need to make sure that as soon as somebody reconnects to your game, you resend the death recap information. Like players are interested again in that when they reconnect. Maybe you reconnect to an already dead player. Then you of course are interested how you died. So the server needs to pick up on that. You just reconnected, your player character is dead, therefore all of the information about how you died needs to be resent, again using an Rmi. Now let's come a bit to the postmortem of what went right in the development of the Reconnect in Hunt and what went wrong. Just in general, some marks. I've been working on the Reconnect feature for the last 9 months, and the feature was released 1 month ago. So there are still some issues with it because, well, there are always issues. But in general, it was released 1 month ago, and the work for this has been 3/4 of a year. So what went right in all of this? Well, one of the good things about Hunt is that it is using a very special kind of visual scripting language. So maybe you're already familiar with Unreal's blueprints or Unity, as I think it acquired Bolt some time ago. So just in general, visual scripting. Well, what a schematic, our system, does a bit different is that it is completely state-based. Here's a little screenshot of how a node graph inside of the system looks like. Basically, if you use schematic, you don't have big graphs or something like this, but most of the time you split your entity logic into chunks, which are state machines. This example, I hope this is readable in the presentation. In this example, for example, you have an entity that can crouch. Maybe it's the player character. So this logical chunk of the player character, this character either crouching or not crouching, this can be put into a state machine. And this state machine has 2 states. Either the player is crouching or the player is not crouching. And if you do something like this, you can move a whole lot of data in your game from dynamic data into static data. In our case, the static data is this whole scripting here, like all of the nodes and what should happen when you enter a state. Like, for example, if I receive a message from my server that tells me this entity is currently crouching, then in response to this, static data will kick in, and static data will play an animation, it will play an audio file. Maybe once we enter the state, there is some custom logic that will be executed in the constructor, and when we leave this state, crouching, then we'll go back to the destructor. And the only dynamic data in all of this is one number, which can either be 0 or 1, because there are only 2 states, like either we are in state 0 or we are in state 1. And even if we were to add more states to this, it's still just a very small number with a very small range. So in terms of networking, schematic is actually quite nice because it is, as I said, state-based, and it moves a lot of data to static data from dynamic data. Now, in that regard, schematic is sort of like a visual representation, or a visual representation of aspects. Like it continuously observes a state of an object, and if this state changes, it senses information of the network. So that is nice. Great. Also, CryEngine takes care of this stuff where if an entity is spawned at runtime, it keeps track of it, and once another player reconnects to us, it automatically resyncs these entities to clients. So that also was quite nice. A lot of work that I, as a programmer for Hunt, did not have to do. So overall, in general, because of the way that schematic works and because of the way how the engine works, handles reconnected player, a lot of stuff actually worked out of the box. Like even if we did not have reconnect in mind from the beginning, a lot of our logic actually already worked. Like when I first tested this feature, I could run around, I could shoot, and even my ammunition was working. And of course, there are quite a lot of bugs. Of course, there were, but like a lot of stuff was already working, which leads us to what went wrong. In this case, what went wrong is that, well, you maybe have heard of this 80-20 rule, where 80% of the work is done in 20% of the time. And once you come to the last 20% of the work, it takes up 80% of the time. I've said that I've been working on this for all in all 9 months now. And the beginning was very easy going. Like I was thinking, oh, wow, I could get this feature running within a month or two. But then like this last 20% of work and all of the bug fixes came in, and they took a long amount of time. And one of the reasons for this was that in most games, the order of data is quite important. Like it is all fine and dandy that we can send over our data using, for example, an aspect. But a lot of time in game development, the order of the data is important. One specific example. Let's go back to my dev recap. The dev recap, it receives maybe the data of how you died at any point in time, but it will only display it when it is in a certain state. The state in this case is when you were killed, the UI notices this, and it goes into a certain state, which roughly translates to, I am waiting for the damage recap data. And if the UI is not in this state, then, well, even if you send the data at some other point, the UI will never leave this state. Basically, in this state, it is waiting for the data to arrive, and only if it has arrived in this state, it will go to the dev recap. So in this case, order was important. We can't just send the data to the client and hope that everything works out, because you have to adjust the logic so that it can handle, well, data at any point in time instead of only when it is in a specific state. So for this, I had to rewrite the UI logic. Or in other cases, the UI programming team had to work on well, other cases. We have a spectator mode inside of the game. It's something similar for this. Yeah, that is basically the same. UI needs to be primed. And in general, with network programming, but especially with the Reconnect, this is just very tedious to test. Like, if you have a networked multiplayer game, most of the time you have to start 2 instances of this game, and then you have to connect these 2 instances, and then you do something inside of your game, and you see whether a bug that you might have has been fixed because of the line in code that you have changed. And this whole setup, the whole logistics of always getting 2 instances of the game to run and checking this can take some time. And for Reconnect, it's actually even worse, because in there, you have to start 2 clients. They need to connect to each other. Then one of them has to leave the game. Then one of that player has to then again reconnect to the game, and then you can check whether the bug fix that you might have implemented actually works. So in that regard, it's not something inherent to Hunt Showdown as a game, but this is just something with Reconnect in general. It's just annoying to test. And the last thing that I want to talk about, afterwards I'm also done, I have 1 minute left, is that even aspects are no golden bullet. And one example that I want to mention here is, again, this crouching state machine. I've mentioned how if I receive a message from the server that tells me that my entity is currently in my crouching state, I respond to that state. Like I play an animation, I play a sound clip, or I execute some specific logic using the node system. Well, sometimes this also is not good, because sometimes the lifetime, or how long I have been in a state, how long an entity has been in a state, sometimes this is important. One example in this is, as I said, if I enter a state, I play a sound. This is all fine if I receive this information shortly after the state has been changed on the server. But if I reconnect to the server, then I have no idea how long this entity has been in this state. Like maybe in this example, this entity has been crouching for 10 minutes already. And I just reconnect to the game, I get to know about the state of all the entities, and I receive the information that this entity is in the crouching state. I do not know that it has been in the crouching state for 10 minutes. Therefore, I receive this information, and in response to this information, I play a sound file. I play an animation, perhaps. But the sound file, it should not actually be played. Like this entity crouched 10 minutes ago. I did not know that it has been in the crouching state for 10 minutes, but I just hard-coded as a response that I will play an audio file when I receive the information that this entity is currently crouching. And in that case, perhaps the sound file is simply misplaced. You can replace the crouching sound maybe with an explosion particle effect. This was actually a real example in Showdown. Maybe you reconnect it to the game, and a barrel that is in the world that could explode is currently in the state that it is about to explode. Well, maybe it has exploded 10 minutes ago, but I have just, as a reconnected player, received the information that it is in the exploding state. Therefore, it is playing a huge boom sound effect and also the explosion particle effect, which should not be the case. You receive false information. Because, well, even aspects, as I said, no golden bullet. Sometimes, as I said, lifetime is important for context here. Now, well, these are just the credits, the spaceships I have from Open Game Art. These are the people who did this, thanks to them. And that was my talk. Thank you for listening.